recording, and we are sharing the screen, and let's do this first one. Cool. So this one says, write a function which takes 2 arguments and returns all numbers which are divisible by the given divisor. The first argument is an array of numbers, and the second is the divisor. So let's see what this one looks like. Cool. So they give us a function, and they give us some numbers and a divisor. And this is a case where they don't give us any tests. They want us to write some tests, but we really haven't talked about how writing tests work yet. So this is like an extra, if you're looking for adventure mode on a codewars, this would be it. But there should be some checks under the attempt. All right. So, but it does give us some sample inputs that if we call divisible by, let me make this a little bit bigger. If we call divisible by and we're given 1, 2, 3, 4, 5, 6, and a 2, we should get back 2, 4, and 6. Well, did they really give you like the same thing twice?
Yeah.
Oh, how helpful is that? Right, this should probably be like a 3, right? So if this were a 3, yeah, it would just be the 3 and the 6, exactly. So this is another one where when you start to look at the inputs and the outputs, right, you'll start to get a feel for the kinds of tools you want to reach into your tool bag to find. So the input here is a what kind of object?
Array.
And it's returning an with just some of the elements from this. So in our list of tools, of array tools, we're looking for filter. So we should be able to return the numbers with a filter. And then what we have to fill in here, right, is return, we want this to be return true if we are keeping this number, false otherwise. Right? So let's make a keep variable, and we want this to be true if we're keeping this number and false if it's not. So we learned an operator that helps us with remainders, the mod operator. So if we ask for this number modulus the divisor, this is the remainder. Actually, let's break it out. This is the remainder, right? Remainder, if we take number and divide it by the divisor, so number is each of the numbers successively from numbers, right? So numbers filter goes through the numbers one at a time, gives us each number. We're going to keep that number in the output if this returns true. Let's get the remainder. And let's return true or false. Actually, let's make another variable just so you can see it. So we're going to keep this if what? If the remainder is 0. Yeah. So if the remainder is 0, when we take this number and divide it by the divisor, we're going to keep it. And inside of this filter function, we'll return true. Let's see here. We got all the numbers back. Remainder is number mod divisor. Oh, sorry, we're keeping it. Yeah, if the remainder is 0. Oh, not return true, return keep. All right, turkey brain. There we go. Return keep. All right, return keep. So go through the numbers, returning just some of them, but only if that number, when we compute its remainder, if the remainder is 0. So let's apply some of our rules here, right? I think this code here is great. If you get to here, this is perfect, right? Let's apply some of our like refactoring rules. So one of them is if we make a variable and we only use it in one place, then we can replace where we use it with that variable and get rid of the variable, right? We just get rid of that keep variable. Let's apply that rule again. We make a variable here, but we only use it in one place. So let's do that. Now the next rule is if our function only returns one thing, then we can get rid of the return keyword and we can get rid of the braces. Right? That's another one of our rules. And our function becomes this. Now we could turn this into an arrow function and get rid of this return here too, but I think this is good enough.
Is there anything else you can use besides filter?
You could use a for each loop, right, and just write it yourself. So you could make let answer be an array, and then you could say for each number. Let's make this back to a function again. If the number, then answer push number, right? And put this inside of an if loop, and then return the answer.
I think that's more what I was trying to figure.
What do I? Oh, I have too many parentheses.
You don't want to make a for loop, but why?
Mm-hmm. Yeah, you could also use a for loop. So if you don't like this, right? So there's this version. So the other one is you could say for let index equals 0, index is less than number's length, index plus plus. Then if numbers index mod divisor is 0, then push numbers index like this. And that ends the if, and this ends the for loop. I have an extra, oh, I'm missing an open parentheses here, or braces there. Right, and here it is with a for loop. This is with a for loop. Yeah, so make an empty, oops. Make an empty answer array, then use our old friend, the plain for loop, to go through every index. And if the number at that index, when divided by the divisor, has a remainder of 0, then take whatever is at number index and push it onto the end of the answer array and return the answer array. I might add this one to the JS iteration little code practice, because this is a good one. This is a lot like if you did the JS iteration practice. This one would be a good one for in there. Cool. Let's look at the next one, which was, oops, which was this one. So this one says, your task is to find all the elements of an array that are not consecutive. Create a function named all non-consecutive. If we have an array, 1, 2, 3, 4, 5, 6, 7, 8, 10, it says then 6 and 10 are non-consecutive. You should return the results as an array of objects with 2 values. I is the index of the non-consecutive number, and n is the non-consecutive number. So it's saying here that this 10 is non-consecutive and this 6 is non-consecutive. If the whole array is consecutive, then return an empty array. The array will always have at least 2 elements, and all the elements will be numbers. The numbers will also be unique and in ascending order. The numbers could be positive and or negative. So we've got to walk through this array and find numbers like this 6 and like this 10. So did someone come up with an English written set of instructions to do this that they want to share? I can tell you what my brain is thinking based on this. What'd you come up with, John?
Well, you could just do if a number.
So I don't. Yeah, so I don't want to hear it in. I want to hear it in English instructions. That's the focus for the practice. So how would you write out a recipe for this?
If the number plus 1 equals the next index in the
So
array.
I'm going to be the robot. Which number are you talking about? We're doing the cup exercise. Which number are you talking about? Right. This is the practice. This is really the practice. This is the practice. Right. So we want to think about it in those kinds of terms, because when we get down to that level of detail, that's where the practice of getting better. Let me see if I can I move this such that it's going to fit on the projector? No. What if we do train? Will this fit on the projector?
If the numbers you're evaluating
What's going on?
in the array equals plus the number you're evaluating plus 1 in the array.
So let's see if we can. What I want is, I want to put this on the screen so we can see it here. Nope, that's still too much. What I'd love to be able to do is like draw on this board, but I can't.
Can you push it closer to the screen?
Yeah, maybe. Get what I want on the screen. Almost. Kind of. Barely. Cool. So we have this array 1, 2, 3, 4, 6, 7, 8, and 10. So this is one of the numbers, and this is one of the numbers, right? In this example, this is what we're looking for, right? It's saying that the 6 and the 10 are non-consecutive, right? 1, 2, 3, 4, 6, 7, 8, 10. It's highlighting the 6 and the 10. So we should look at the 6 and the 10 and ask ourselves, what's unique about them? What's unique about the 6?
The 5 is missing.
The 5 is missing. So we're kind of looking backwards. What's unique about the 10? The 9 is missing. So we're kind of looking a little bit backwards. Could the 1 be non-consecutive?
No, there's nothing.
Probably not, there's nothing before it. So maybe our instructions are, start with the second number and look backwards to see if the number before it is 1 less than itself. So the recipe would be, start with the second number in your list, look at its value, look back 1 to see if the number before it is equal to the number minus 1. If it is, leave it alone. If it isn't, like, we got to deal with this output thing. It's one of our candidates. So we're going to start here, is 2 a candidate? No, because 2 minus 1 is 1, and there's a 1. Is 3 a candidate? No. Is 4 a candidate? No. Is 6 a candidate? Yes. So it looks like we have a loop that starts off 1 past the beginning and goes up to but including the last. And we can look back one element. We can do that because it tells us that the array will always have, oh, you can't see it. The array will always have 2 elements, and they're always going to be in sorted order. This would be harder. That algorithm wouldn't work if they didn't make that guarantee of there always being 2 numbers, or if it didn't guarantee that they were in sorted order. So let's see if we can figure out how to write that. Oh, and here do they give you nothing? No, there's the function. Right, so we said go through the array starting at the second index. Well, unfortunately, JavaScript doesn't really have a built-in for that. So let's just default to our old friend, the for loop. Instead of index starting at 0, we should start it at 1. And let's go to index is less than array length. And then index plus plus. And then let's make it a candidate if what? If we look at the array at the index minus 1, if that is not equal to the thing at the array index minus 1. Let's write this out a little bit more. Let current be array index. Let previous be array index minus 1. This one is a candidate if current, if previous is not equal to current minus 1. Right, that's why that 6 is going to be a candidate. And then let's just console.log all of our candidates. Candidate. Right, I'm not going to worry about the output yet. Let's just see if our selection part works. Right, false, 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 true. Let's log the current and the candidate. Hey, we got a 6. We got true for 6 and 10. Those are the ones we're looking for. Now we got to think about this output. Let's make an answer array. And now, what we wish we could do is just say answer push the current, right? This is kind of like the other one that we did. We just pushed that onto the, and we return the answer. But it's not quite what we're looking for, right? It's a little bit harder than the other. Oh, if this is a candidate, then push the answer. If it's a candidate, we'll push it, right? So instead we got 6 and 10, but we don't want an array of 6 and 10. We want an array that looks like this, right? It's an array of objects. So let's make an object where, well, what's, instead of the 6, right, we want n being 6. So let's make an object that has n being the current, and let's push this object instead. Let's see if this gets us closer. Aha! We got n6 and n10, but we also need this I. Where am I going to get I from? Index. So I think it would look something like this. So this should be a pretty close, except for this business here about having to format this object specifically. Should be a pretty straight transcription of our algorithm that said start at the second element. Consider this element a candidate if the element that comes before it is not equal to the current element minus 1. Add that candidate to the output. Right. Start at the second element, go through them one at a time. It's a candidate if the previous element is not the current minus 1. If it's a candidate, put it on the end of our answer, but in this funny object style, return that answer. Questions?
Would it, you setting yourself up for a mess if you first map over everything and turn it into an object with index?
Yep. Well, no. You could turn that into, you could turn this into a map, but I don't think you need to. If you wanted to do this with filter, we could.
I have a question before you go
Mhm.
to that. When you push the object, how does it know what you're pushing?
The variable is right here. Let me call this something other than object. Let me call this candidate, but reformatted in the way the We could use for each. I'll do it with filter, which is gonna be kind of the same as for each. So all we're doing is we're making a little object variable right here, and we're just pushing that into the array. Right. So normally if we were just making arrays, right? Names is a blank array. Right, and we're doing names push Gavin. Right, we just get this, right? And then if we names push Jason, right, now names has this. But we could have people being an array, people.push, and we could make an object. Name is Gavin, and score is 42. Right? And now our people array is an array of objects. Let's push name is Jason, and score is 100, right? So that's just an object. But our people array is an array of objects. Right? It's no different than being an array of strings. Now it's an array that this is the first element, but it's an object. This is the second element, and it's an object. Arrays of objects. Now I could apply my refactoring that says if I make a variable but I only use it in one place, let's get rid of the variable and put the thing in there. Right? So you could do this, and if you wanted to reformat it a little bit so it looks like what we just did in the terminal, right? Like this. This is kind of like this, pushing an object onto the end of that array, an array of objects. And if we were to simplify again, let's apply that rule again to candidate. That still works. Let's apply the rule again. Here's current. Here's previous. Here's current again. We can get rid of these little local variables. Let's do it with filter. So if we say array filter, we're going to get the number and the index but what's true? If the index is 0, is this element a candidate? So let's just return false. So if the number is not equal to the array at index position -1, return true, right? This is a candidate. Otherwise, return false. And then filter is already returning us our answer. Except, right, we got 2, 3, 4, 5, 6. If a number is not equal to array of index -1, return 2. We got all of them. Why did we get all of them? We should have gotten just the 4 and the 6. If the number is not equal to the array index -1, r index -1, return true.
Should it be equal or not equal?
But we want all the ones where this is not true, right? Let's console log, let's debug this. Let's console log the left-hand side and the right-hand side of that if statement. I'm gonna make this a little bit smaller so I can get my, nope, it's not that, it's this. So 2 and 1, 3 and 2, 2 gives us 1.
Do we want to say if the number is not equal to array index -1 plus 1?
Oh, it's -1. Yeah, it's this -1. Yes. This is the value -1. Yes. Right. oh, it's number minus 1 versus this. Right, it's if the number minus 1 versus that. If the current number minus 1 is not that, yeah, so now we got the 6 and the 10. Right? Except we want this index and the n, right? But filter doesn't allow us to change the data. So this filter is right, except we need to do something else with it first. So what if first we made a new array? Let's make a formatted array. As we take the array and let's turn it into an array of objects where I is the index and n is the number. Let's see what that looks like. So let's just log out this format. We're going to take the array and go through them one at a time with the number and the index and turn it into an array of objects where I is the index and n is the number. Oh, and I'm missing, I've got to say return this. Okay, so this kind of looks like the answer, right? But it's got too many elements. Now I could say go through the formatted objects. Now instead of a number, it's the object. And here, right, is the object's n, is the object's n minus 1 not equal to array of index minus 1. Dot n. My brain is rusty this morning. Right, and this passes. Let's get rid of the console log. So first, turn the array into the kind of data we want, and then filter it. So we could apply our little refactoring here, and we could take this map and put it here on the end of the filter. Right? You could do something like this. Like first, let's make this a one-liner. So if you were trying to be fancy and slick, you could do this. Right? Take the array, map it into this, and then filter it. I think this is a little bit easier to read. We can apply our other rule, which says if we have a condition and we return true and also return false, that's the same thing as just returning that condition. Anytime you see if condition return true, else return false, that's the same as just saying return condition. These are the same. If you have this, that's just the same as saying return not condition. And maybe put parentheses around it, right? So if the condition is false, return false. If the condition is if the condition is true, return false, and if the condition is false, return true. That's just returning not condition. So we can apply that rule here to tighten this code up a little bit. So maybe it looks like this. If you're trying to do it with just map and filter.
Would
Question?
you mind reading that in English for me?
So
Object n minus 1, like what does that say?
yeah, so let's go through the whole thing. Let's go through our array one element at a time, getting the number and the index, and turn each of those into a new object that has an I attribute equal to the index and an n attribute equal to the number. So what comes in is an array that looks like 1, 2, 3, 4, 5, 6, 7, 8, 10, right? Let's turn this into an array of index is 0, n is 1, index 1, n is 2, so forth and so on. Index 2, 3, 4, 5, n is 2, 3, 4, 6, 7, 8, 10. 8, 10, 6, 7. I have a mistake here. These are closing objects. Put some space in here to format it nicely. Right, that's what this map is going to do. So we know the output needs to look like this, so let's turn the input into what the output might look like. So that's what this, right? And call that new array formatted. Right, so this 1, 2, 3, 4, 6, 7, 8, 10 becomes this. Right, the I is just the index, and n is the number. Right, 1, 2, 3, 4, 6, 7, 8, 10, and the i's are just the index. Now, look through formatted, one element at a time. If we are the first element, index 0, we never include that in the output. Right? We know it's not possible. We know it's not possible because it can't be out of order. It's the first element. Right? That's what this does. So object is the current element in the array. Kind of looks like this. I is 6, n is 8. So object.n would be 8. Object.n minus 1 would be 7. So consider if 7 is equal to element at the previous position, previous index, index minus 1, and included if it is not there. Right? So object.n in this case would be 8. If this was our current object, right? We're walking through this one at a time. This is the first object we're going to get here. First object, second object, third object, fourth object. Right? So we're looking to say, if we take this object.n, 8, and we look one element back in the array, is that a 7? Right? We could say object index minus 1 dot n. That's the other thing we could do. Right? We don't have to go back to the original array. We could look back in the current list, sorry, formatted index minus 1 n. Right? We could look at that as well. Something like this, right?
Yeah, the problem was I just didn't account for starting at 2.
We also don't need the index here because object.I is the index. So we could get rid of, this is object.I, right? Because object.I is the same as the index. So it could be something like this. And there's ways to squeeze this code down even more if you're trying to code golf it. Right?
Why do you not have to put the .n before? Because the .n to me would say that you're comparing the number. That's
Yeah.
what was really throwing me off.
Yeah, so formatted, so if I just go back to the array,
Yeah, before you have array.
right, so what is array? Array looks like this. Right, so if I say, if I'm on this index of the formatted array, right, I'm at the same part of the array, the R array as here. So if I'm here in this index of this array, I can take the index here and go 1 minus it back into this array and get the 7. Right, so I could say R of object.I minus 1, right? So here the n is 8 and the index is 6. Well, if I go to index 5, 0, 1, 2, 3, 4, 5. Right. So because formatted comes from a map, there are going to be as many elements in formatted as there are in this R array, and I can do the lookup in either array because they're the same length. So I can either go to R of object.I minus 1, or if I go to formatted, then I have to ask for n because this is an array of objects, and I need the n object from it. Play around with it yourself. I'll post the code and see if you can figure out like why that works. Do some console.logs and look at the results. Let me code golf it for those who are interested in the code golf. So if this is return false, I could say if this is not the 0th element, and this. What the? Go away. I don't want the debug console. So, right, if the object index is 0, this would be false, and I would reject this. So that's how to do that in one line. Right? If the object index is not 0 and this is true, let's apply this rule, right? Cool. Now we could apply this rule here, except we kind of use formatted here. So let's add back in the index and formatted here. Let's tighten this up and now replace this here. And then let's move this down here. For anybody who cares, that's how to do it in one line. Go through the array and turn it into an array of objects. Then filter those and take the object, each object, its index, and the array. Because remember, we can get the array back as the third element, and then the rest of the code is the same. This is that as a one-liner. I don't know if it's a great one-liner, but it's a one-liner. So for anybody who's trying to the array. Right. Remember that the three things that filter, map, reduce, etc. get is the object, the element, the index, and the array. So I need this array after the map. So the thing that I'm filtering over on is the mapped thing. So I need that back because I'm trying to compare it to the one before. And so if you're interested, play around with this version of it and see what you get. There it is as kind of a one-liner.
Do people mostly write it out a long way and then shorten
Yes,
like that?
and I probably wouldn't do it this way in production code. I would probably do it the way I had it before. I would probably stop somewhere around here. I would stop somewhere around right about here is about where I would probably stop. Because I think when you start to jam those together, you lose some clarity as to what it is you're doing. So giving variables names helps. But I think it's also good to see these done in one-liners because it gives you the perspective of why are these iteration and enumeration tools so powerful. It's because they can be chained together in ways to manipulate data. And like I said last week, there's a whole part of like, if you're into big data, right, or data warehousing or ETL, extract, transform, and load, right? If your job involves manipulating data from one system to another, that kind of chaining of how am I going to take input data, turn it into something else, filter it, transform it, massage it into another format, and send it into another thing, being able to think in these chains of filters, maps, everys, any's, reduces, becomes pretty powerful. And when you can start to think about these things as like a pipeline of processing, I do this to the data, and then I do this to the data, and then I do this final thing to the data, and that's the answer I want. Sometimes seeing them chained together helps visually connect those ideas. But I would probably stop from a code perspective somewhere around here. I think anything shorter than this starts to obscure what's happening if you were like giving this code to somebody else. Cool. Yay, Code Wars. All right. So let's do like 12 minutes of getting set up for working on tic-tac-toe as a React app. So I think we should do this as a code along, like everybody kind of code along. And this will get you like back in the mode of React apps. So
Gavin, can
Yep.
I take 5 back to the restaurant?
Oh, sure.
I don't wanna miss it.
yeah, let's just do that now. Let's just do our break now then and come back. So let's just come back at 11. We'll just do the break now, and then when we come back, we'll do the setup. If on break, if you want to do a create React app for React tic-tac-toe, that's what we're going to do right when we come back. So let's take a break and we'll come back at 11.